All right, so we have finally reached what will be the ocean floor. We've talked about how deep the ocean is, how it's salty, how it moves. So now we're going to take a look. We're going to go on a journey under the sea. If you've been to the beach, you know that a really fun activity to do is jumping and playing in the waves at the shoreline. But my question would be, if you think about it, if you just kept walking out from the shoreline of the beach through the waves as the water got deeper, but you could still, if you just kept walking, where would we end up? Like, where would we come back out? And what would we see or experience on our walk? Because we'd have to walk along the ocean floor, obviously. Well, if you wanted to know, if we were at Virginia Beach and we were to walk in a straight line, we would end up and come back out in Portugal, which is over in Europe. It's right next to Spain. And that's where we would end up. As far as what we would see along our way, a vast majority of things. The ocean is just so fascinating and so different than anything we have here on land. I'm hoping that obviously we can get technology and things to explore it more and learn more about our ocean, which takes up, as we already learned, 70% of our planet. Everything you can see on land, you can find on the ocean floor. So let's go down where it's wetter. Darling, it's better under the sea. All right, so our first part of our ocean floor is called the continental shelf. Here is the drawing. On our note sheet, I use yellow to identify this section. Notice that the beach part is sand colored, right? So that's the beach, and you see the water starting. So the yellow section is our continental shelf. So our continental shelf surrounds all the land masses, like all of our continents, hence the name, continental. And it's this really wide ridge, and it's the shallowest part of our ocean floor. It's mostly flat, and it's made of sand, which is the other reason I chose yellow, because usually when you color sand, you use yellow. It's made of sand, and that's yellow. So that's why I color coordinated continental shelf to be yellow. And that's actually what you're standing on when you're at the beach. I know we're drawing lines between each section of the ocean floor, but it is all one continuous thing. So even though the beach and the sand at the beach that you play on and visit is different than as if we actually went under the water, it's still part of that continental shelf, that edge of the continent. And our continental shelf typically goes out about 40 miles from the shore. And the water only gets to about 655 feet deep at the max. I know obviously our walk along the ocean floor is hypothetical because we would drown, but I'm giving you the real numbers. So our continental shelf extends to at most 655 feet, which would be 100 to 200 meters deep. This is pretty much where you find all your ocean life. This is the sunlight zone in its pretty much entirety, because the sunlight zone we said went to about 600 feet or there's abouts. So this is where most of the things you think of live and reside. Some pictures of continental shelves in different illustrations. So obviously you can see in the picture above me, it's a nice picture of how wide and flat the continental shelf is. In the picture up in the corner, is just another different drawing of the continental shelf, kind of similar to our notes. And lastly, this picture next to me I really like because it shows you what it looks like in real life instead of just a drawing. So all the continents actually, they don't end where you think they do. So like you can see here, we have South Carolina, North Carolina, and that edge is where we think the continent ends because that's where the ocean meets it. So we can't go any farther as humans. However, that's not true. As you can see the shelf there, that line, okay, it extends out that much farther, the continent does, before it actually turns into like the ocean, like, and it goes down even farther, if that makes sense. Into our next part, the continental slope. So our continental slope is where it drops off from the shelf. And it's a very drastic drop off. It's very steep. It's almost like a plummet, like a roller coaster, like one of those really high ones, and it just goes down really fast. That's what the continental slope is like. It's made of mud, which is why I chose brown to represent it, because mud. And then it can be as deep as 9,800 feet or even 13,000 feet. And this just depends on where you are on the shelf when the slope starts or how deep the slope goes. As far as metric numbers, this would be 3,000 to 4,000 meters. So this is the entirety of your twilight zone, because we said the twilight zone goes to about 3,300 feet. And so the continental slope takes up that entire portion of our depth zones. And it actually extends a little into our midnight zone. All right, some pictures of our slope here. Again, you'll see the picture in the corner that's like where I am. Mimics the continental shelf picture I showed you, but here the slope is highlighted, how it kind of just cuts straight off. The picture above, again, is just another different rendering. And I like the big picture to the right because now it's not the actual thing like ahead of the shelf, but it's a good showing of what that would actually look like and how it just like plummets downward from the shelf and just woof. That is the end of your continent. The slope, that's like when you draw, that's your outline of the continent, is the slope where it just stops. All right, then we come to our continental rise. If you haven't figured it out yet, we're still kind of dealing with the continent since all three of these ocean floor sections have the word continent in them. Continental shelf, continental slope, continental rise. All right, so this, I used orange to like separate it from our other parts of the ocean floor. It is found at the bottom of the continental slope. That makes logical sense. It's where we're going. And it is made of sediment that has been washed off or pushed off of the shelf by like ocean currents and has slowly fallen down to the bottom. I chose orange because sediment's like the little like silty stuff you'd find at the bottom of a river. It's where the salt comes from, if you recall. That makes the ocean salty. And so it's kind of a mixture of like sand and dirt and mud. So I already used yellow and brown. So I chose orange because it's another kind of sandy color. Anyway, and so the sediment all collects at the bottom and it forms this little bump. Or it could be a little bit more gradual, like a ramp, depending on how much sediment is swept down there. Will obviously collect more into a bump or more into a gradual slope. Some pictures. Okay, so again, you can see the picture that I keep using for each part. Above me, where you got the shelf and the slope, and then the rise. This one is not as distinct, but I really love the picture above that. It shows a great rise where the rise is in brown. That's obviously a more gradual one than a bump, but I like its rendition because it's very easily assumed that things came off the shelf and it's kind of just settled there, and it has evened out our drastic plunge of the slope. And then the last one to the right is a little different. It's almost like a 3D kind of thing, where you can see the side where the slope is, and then you have this like a little, like the slope is super steep, right? And then it's a little bit less until it bottoms out and becomes a flat line or a straight line. It's that little bit of cushion between the steep and the floor of the ocean. All of this is the ocean floor, but the very bottom, we'll put it that way, okay? Also, I forgot to mention, there's no technical depth for the continental rise because it varies, because the slope varies. So we said the slope can be anywhere from 9,800 feet to 13,000 feet, which is 3,000 to 4,000 meters. So it's safe to assume that the continental rise, since it's found at the bottom of the slope, would be near those numbers as well. So like if the slope ends around 9,800 feet, then the continental rise would be 10,000 feet deep. But if the slope ends at 13,000 feet, then the continental rise would be more like 13,100 feet because it's just at the bottom. So the depth for this can vary depending on where the slope ends. All right, we have reached the bottom, the abyssal plain. Remember how we said the midnight zone started up where we're talking about with the slope and went to until the abyss, and that we didn't know an exact number for that because it varied where you are. We're here now. This is the abyssal plain. This is the abyss. I chose a dark blue because it seemed appropriate. So the abyssal plain is wide open and flat, just like the plains or the Great Plains that you learn about in history with the Sioux Indians out in the like Midwest of our country. The abyssal plain does not have long grasses and such, but it consists of the same kind of thing. It's that nice open, like prairie-like feel, except you're in the midnight zone, can't see anything, it's freezing. But you know, same thing. So our ocean floor starts right after the continental rise, so around 13,000-ish feet, or 6,000 meters, and it can go as deep as 19,690 feet, which is 2.5 to 3.5 miles. Again, just like when we learned ocean depth, the ocean goes on what seems like forever. And on the abyssal plain is where you'll find any of your other land features. So the plain itself is flat and wide like the Great Plains out in the Midwest. But this is also where you can find mountains, you can find canyons, valleys, hills, anything you find up here, you can find down there. And it covers 30% of the Earth's surface area, which is a pretty big part actually, that 30% of the entire Earth's surface is the flat abyssal plain. That's a big chunk of it. some pictures. Okay, so again, above me is the picture I keep using for each of our parts. So you can see the abyssal plain is where it has flattened out. Okay, and to the left, I like this picture because it shows a bigger bit of the abyssal plain than the other two pictures, because again, the abyssal plain is probably your biggest part of the ocean floor, because like we just said, it covers 30% of the Earth's surface versus the shelf and the slope. Like those were your medium for traveling there, for getting to the abyssal plain, but the abyssal plain is the biggest part. So yeah, these are just some pictures of all of them together. Last but not least, we have the ocean trench, which I chose black. And it makes sense as to why, because deep sea or ocean trenches are the deepest part of the ocean. They go farther than the abyssal plain because they're like a giant hole in the ground. The Mariana Trench is the deepest trench on the Earth. And it's so deep that Mount Everest, which I'm sure you've heard of, that's the tallest mountain up here on land. If we were to take it and put it in the Mariana Trench, it wouldn't reach the bottom. It just kind of blows your mind. So the tallest thing we have on Earth doesn't even make it to the bottom of under the Earth, if that makes sense. So like under the water. So the deepest hole cannot even be filled by the tallest mountain we have on Earth. I guess that's a better way of saying it. And the deepest point in the Mariana Trench is called Challenger Deep, and it is 36,200 feet below the surface, which is about 7 miles. Not quite, but almost. So this is how deep the ocean can literally get, is 36,200 feet, because that is the deepest point in the deepest trench. And while it is immensely punishing, right? Because the farther down you go, the darker it gets, the colder it gets, the more pressure there is. But 3 people have made it to Challenger Deep, the deepest point in the ocean. The first 2 went together, Jaques Piccard and Walsh. And they were the first ones who went down there. They made it in this like special submarine, like sub vessel. On their way down, a window actually cracked from the pressure, which is like terrifying, but they were all right. They made it. I know Walsh is still alive today. I don't know about Jaques Piccard, and I should have looked up the year they did this in, but I didn't before recording this, but I'll post it in the little video description for you. Anyway, and the only other person who's been there other than Jaques Piccard and Walsh, which were the first, is none other than James Cameron. That name I feel like should be familiar to you, and if you're trying to place it, he is a famous movie director. You have seen his movies. He did Titanic. He did Avatar. Those are probably the 2 main ones you guys would know, like right off the bat, along with many others. Oh, The Abyss, I believe, is also his. I have not seen it, but would make sense, right? Because he went in the ocean. And I'm actually going to post a cool documentary of him preparing to go and doing the dive, and I think that's really cool. So I'm going to include that link to that other video if you would like to watch it, because it's actually it's cool. So a few other landforms you can find on the ocean floor. The main one would be your Mid-Atlantic Ridge. It is the longest mountain range on Earth. It starts near Iceland which is up at the top, and continues all the way down to the tip of Africa. So the picture I'm showing you is if we sucked out all the ocean. So this is just the land. There's no water in this picture. So you can see the mountain range there. So not only is the deepest hole in the ocean, our longest mountain range is in the ocean, not on land where we can see it. We would have to cross over the Mid-Atlantic Ridge in order to get to Portugal on our walk across the ocean floor when we left from Virginia Beach. And then you might also see seamounts. You might see seamounts, which are just individual mountains that are underwater. Now, the important part is they have to be underwater once they break the ocean water, like the surface. Once they break the surface, they become islands. And volcanoes, obviously, you can find in the ocean, and that they make islands, which is Hawaii. That's how Hawaii was made. It's a bunch of volcanoes that are erupting lava, right? Magma. And as it cools and hardens, it gets taller and eventually pops out of the ocean water, the surface, and makes an island. And then we populate it because that's what humans do. And many seamounts are also volcanoes. The individual underwater mountains are also volcanoes, but they might be dormant rather than active. All right, the last thing I want to leave you with is a little ditty to try to help you remember the parts of the ocean floor. It's a very simple little song. I'm going to sing it once so that you can hear the tune in case you don't know Frere Jacques. And then I'm going to sing it a second time. And while I won't know if you sing along, I would encourage it to help it stick up here. Okay? So here we go. I'm going to sing it first time so you can hear it, the little tune. And then I'll sing it a second time. And I hope this helps you remember our ocean floor. Continental, continental, shelf then slope, shelf then slope. Continental rise, abyssal plain, continental rise, abyssal plain. Ocean trench, ocean trench. See? Simple. Okay. To a tune. So now I encourage you to sing along. The words are right there, right on your screen. All right, here we go. 3, 2, 1. Continental, continental, shelf then slope, shelf then slope. Continental rise, abyssal plain, continental rise, abyssal plain. Ocean trench, ocean trench. That one's always fun to end on because you can go deeper than your normal voice. Anyway, hope this helped. Hope you learned something. I always like sharing, and I will see you to finish up our ocean unit with the ecosystems.